It's my pleasure to introduce you to Jörg Schad. Jörg is the head of engineering at NextData, the company that I have started a little while ago to build technology to support data mesh implementations. And he's bring a wealth of knowledge, kind of both from AI and ML, graph databases, containerization technologies with Mesosphere, and he will share his perspective and our experience on intersection of AI and data mesh. Please welcome Jörg.
Thank you so much.
Thank you and good night.
Thank you so much. Have an awesome time. Bye-bye.
Thank you so much for having me, and I'm also very grateful I don't have to stay up right now and call in from San Francisco, but I can be here in person. So thanks again for organizing all of this. As already mentioned, I want to touch up on a little bit the state. Where have we been? You mentioned it's been 6 years. And where are we actually going? Is it like relevant these days? Especially also like I really liked your GenAI question there. So we'll dive a little bit into that. How many of you know the poem, Now We Are Six? I mean, maybe it's a more like American thing, but it's something which, when I was contemplating about where are we right now with Mesh, I did what you do these days. I actually asked ChatGPT, or it was actually Gemini in this case, to actually translate that poem like onto Mesh. So now we are Mesh. I can share that later. I think I had it shared via Twitter and Blue Sky earlier, but I kind of wanted to know like where are we like in this age of 6, and this last part here, so now we are Mesh, and oh, what bliss, it's better than the old abyss. We scale with trust, we are bold, not brash, because at last we understand the mesh. And I was thinking about that, and I'm questioning myself, do we actually fully understand the mesh? Are we actually there? So that's what we're going to dive a little bit into during this talk. Jean-Marc already did a great job introducing myself. Maybe just my personal perspective. I feel for me this is like, even though I've just been here in that community for a year, it feels like so familiar because like it's bringing all of my like past experiences together. So I started a really long time ago on implementing distributed database systems. So during grad school days. And then also like over at SAP, at Mesosphere, I'm not sure who's familiar still with Apache Mesos. It was kind of like pre-Kubernetes, but also we were heavily involved in like the first implementation of Kubernetes. I recently checked last week, and all my code lines I contributed are now out, but it was a fun time back then. And I feel right now it's actually bringing all of that together, that data side, the orchestration side, and also, written containerization for microservices, and now we are like a bit in the writing containers for data and data mesh. So, data mesh. I feel actually, and this is the other thing, like looking back at my career, I wished it had been around there. It would have saved me so many sleepless nights when I had to retrace like some kind of lineage, trying to figure out where the feature stores. So I actually feel it's more important than ever. And as Jean-Marc already mentioned, like if we look around in this like world outside, there are like new projects every day, like a new hype every day around like GenAI, some new projects, some new agent, some new model out there. So it's changing so quickly, and we are seeing a lot of companies struggling to kind of keep up. So for example, things I heard was like, oh, we have so many great prototypes. They're like in a Jupyter notebooks and with some artificial data, but then we fail to actually put that in production. And I think this is kind of like this important gap. I think I wouldn't necessarily say that it's missing, because there has been work on that, but I think the true value of GenAI actually comes from if we can connect it to our own data in a safe and specific fashion, and we'll dive a little bit into that during this talk. So I think data mesh and domain-driven design in particular is a very important glue to enable this like fast-paced moving world while being this steady foundation down here for this innovation on top there. what has changed there? What is changing? So I think previously we often were thinking of like, I call it like semi-human consumption, right? There was like a data analyst writing a pipeline. There was someone writing a particular Spark job. Well, there was still kind of like the human in the loop. And nowadays we are dealing with autonomous consumption. It's this agent running there, and the agent is actually going in and taking decisions by itself, right? There isn't like this safety net of a human who can say like, this doesn't make sense here. And the other aspect of that is I think it's just a sheer scale, right? How often an agent, how quickly it runs, how many agents we are having. I think that is a different scale compared to the world before with semi-human consumption. So what do we need to make that happen? So I would call it like AI-ready data management, so the stable foundation underneath all of that to enable this fast-moving world and innovation, safe innovation on top of that. And I think this is also like the first property here. We need safe data access. So I think safety comes from like two parts here. And the first of all is the governance aspect. I think later today we have a number of talks on that topic as well. But basically, how can I enable those autonomous entities running there to not break, to not spill any data out there? I think many of us might have read about like at Microsoft when they had the first instance of their internal chatbot, it actually leaked secret management emails to the other rest of the team, which maybe is not the best thing. So how can we actually prevent that? I think the other dimension of safety is the data integrity, right? Because it's autonomous consumption, as with any ML model, if I feed it bad data, I'm gonna get shit back. So if we can make that safe, because there's no human in the loop who's kind of like that brake switch, it's just gonna keep on running. So how can we make it safe on those two dimensions, at least those two dimensions? I think the other one is domain specific, and Jean-Marc mentioned like these 3 S's just a second ago. I actually feel like for AI-ready data management, we need that 4th S, specificity. So, and we'll touch up on that also a bit later in the challenges, but I see a lot of people who are basically like, oh, I just need to put an MCP server in front of my Snowflake. I just need to put an MCP server in front of my data lake and all my problems are solved. No, you're actually overloading your system and you end up with hallucinations again, because if you give too much context to your LLM, to your chatbot, to your agent, it doesn't know like what data it actually needs. So we'll come back to that, but as we're here at DDD, you can imagine that probably some domain-driven design and data mesh is a suitable answer here. The last part is, we touched upon that already, which is with scale. It's just the sheer scale of the autonomous consumption, right? It is just a number of agents consuming my data. It is the number and the speed. Humans are like orders of magnitude slower than agents in consuming it. So how can we achieve that without creating like a centralized bottleneck out there? So, big picture, and I think that's going to look familiar to many of us just from the data, having worked in data mesh side, is how can we solve this data platform bottleneck here in the middle? And this is for me like one of those interesting realizations. Actually, this isn't different from the other challenges we have been dealing with before. It is at a different scale, but it's not like a fundamentally new problem we're seeing here. So we've seen that before also in the analytics world. We've seen that before also in the general data management world. And it's basically, it is this problem here that we have a number of dimensions, and so the potential configurations to manage across different database services, across different cloud providers, across different applications, it just becomes like an intractable problem out there. So still, AI isn't changing the underlying problem, but it's adding like a number of dimensions here of variations and also the speed. Okay, that brings us to data mesh. Maybe just a quick raise of hands. Is anyone new to data mesh here? Cool, welcome. Welcome to the community. Really cool to see some hands up here. So data mesh was actually, if you just jump back here, when Jean-Marc came up with the first ideas and concepts of data mesh, I think, Arif, where are you? There. You mentioned that very nicely at the meetup on Wednesday. She in anger, she designed that because she was seeing those problems out here. And this was basically this problem here in the middle. And so it started by asking questions. What if we stopped applying, like doing all those small things? In my own worlds, I would say, what if we stopped applying like small patches, putting small bandages on top of like a dying person or a severely injured person, maybe is a better analogy, and actually fix the underlying problem. I feel if I look at like a modern data stack, there are so many different tools we put on there, like lineage tracking, catalogs, etc. And I have to bring all of that together. And often it feels like putting little bandages on top of those injuries instead of solving like the underlying fundamental problem. And so I think this is actually, this was like part of the original motivation, right? By going from like a centralized ownership to a federated ownership, as we learned, which might be the better term, from a monolithic architecture to a distributed architecture, and actually distribute that also operational knowledge out there. So how does it work? So data mesh is actually breaking those pipelines apart. And it often reminds me to kind of like the switch over to microservices by breaking a big monolith apart and enabling teams to work on like smaller independent parts and have well-established interfaces in between. So for example, here, just kind of bringing that back to like the different domains. If you've read the book, there's kind of this ongoing example, DAF, around like a Spotify kind clone. And there we have different domains. There's a playlist domain, media player domain, partner domain. And those are different domain teams with also different motivations, different focus areas. And they can actually maintain those data procs instead of maintaining all those different pipelines. To all of those who haven't raised their hand before, I think this is part of the motivation for data mesh, but I think this is kind of bringing all of this together in this domain-driven world by applying the same principles to data. So 6 years later, right? We've done that for 6 years. Is everyone happy? What we are hearing, probably not. So we are often hearing things like, oh, we choose in data mesh, we tried it, but the implementation is really hard, the technology just isn't available yet. We've implemented parts of it. I think on Wednesday we talked about that at some companies, even the terms data products has become kind of has received a very negative connotation by now. So I was, for example, in a call last night also with an Australian customer of ours, and they were also like, oh, we have to call it AI products now, because basically first of all, because AI is everything is AI nowadays, right? So that aside, because basically the term data products has received so much negative pushback by now, because no one really knew how to implement it. So is everyone happy? Probably not. How can we get there? What are kind of like the problems of why people are not happy? And I think a lot of that comes down to data mesh anti-patterns, where people don't apply and therefore cannot leverage the full potential. I remember giving a talk on anti-patterns for container orchestration pretty much like 8 or 9 years ago, like in the early days of Kubernetes. And I feel we probably would need like a similar talk in this community, talking about what doesn't work. So I think a lot of talks I see in the community are around what is actually working. I think if we shared more openly like what hasn't worked, we can prevent a lot of pain for other people to run into the same mistakes. I think the first and probably biggest challenge we are seeing is a partial implementation. So I think some companies, they go and they define data products as just kind of like a maintained view on their central data mesh. So they're deploying tools and then they're rebranding kind of like their warehouses as data products. So if we go back to the principles of data mesh, domain ownership, data as product, self-serve data platform, and then federated computational governance, they only take like very small slices of that, right? So they implement, for example, domain ownership in a small part, data as product is their interpretation. Oh, it is basically a view on top of our data warehouse. And then also on the self-serve platform, they kind of have it, but it's still responsibility across the team, right? It's still not a fully true self-serve platform. It's still this one data lake in between. And often what we are seeing is also like federated computational policies and governance is simply left out because it's perceived as too complex, too hard. This is why I'm actually happy we got like some more talks about this topic today, because I think it's part of it. And then this actually explains why people are not getting the full benefit of it, because they are only taking slices of it. To go back to my earlier analogy, they still take like small bandages and they are not solving the underlying problem. I think the second problem is what we kind of coined internally as open loop data mesh. So open loop data mesh, it is very similar to what we described before. It is still when people implement something for the analytical plane on top of the central store. So basically, all the operational data is flowing into the central warehouse, and then we have built those data products on top. So we have static data products. They are updated just whenever the data lake, data warehouse is updated in between, and it's built downstream from there. And so often the data is only usable for analytics, and it feels fairly dated. As kind of like the opposite, and I think this is kind of like along the terms of the initial vision shared by Jean-Marc, then the closed loop data mesh, right? So here we actually have a closed loop with the operational applications directly to the data products without having to go through the central bottleneck, right? So going back here, there's still this central bottleneck controlling all of it. But basically, a data product, it should get updated whenever I have like new operational data, and in particular, I have the chance of updating them independently, because they are independent entities. I think the new challenge coming in here with the autonomous consumption, this is what I mentioned earlier. I see a lot of people, they're taking their data lake, they're taking their Snowflake instance, and they've seen, oh cool, there's this MCP server, let me put that in front of it, leaving aside all the problems with the MCP protocol nowadays, authentication, authorization, etc. But they basically feel like, oh, I can just expose that to the agent and LLM, and I'll be happy. Unfortunately, that's not the case. If I just blindly expose like my big chunk of enterprise data, the LLM will just be overloaded with too much unspecific information, overloaded with too much context. I will incur cost for the context and processing of that, and I won't get the results I want. I'll usually end up with hallucination again, because the LLM has too much unspecific information to choose from. What is the answer? What can we do about it? And answer, of course, needs to be related to data products. As mentioned earlier, to kind of like differentiate a bit from the different interpretations of data products, we are using that term autonomous data products, and I'll explain a bit what we mean by that. But basically, apply the data mesh principles. And so for us, an autonomous data product, it is not just a static view. Let me just expand all of that, yeah. It is not just a static view on top of it. It's actually a self-autonomous, to reuse that term again, which became popular also as agents. It is a self-contained entity controlling all aspects of that data lifecycle. So each data product actually has its own lifecycle, from being triggered from coordinating the transform, from updating the output, from promoting the output right after having run all the validation steps, and also contains all the metadata and everything contained in one unit. I often see it as like very similar as a Docker container or as a container in general. If I give you a container, you know how to run it. It's Podman, it's Docker run, or whatever tool you want to use. And everyone knows because it has a standard interface and it contains all the other parts. I think very similar about data products. If I give you the URL of a data product, you should know how to use it. There is a well-defined API. So if I'm an application developer, I can simply develop against that API, and I don't have to worry anymore what is underneath, what is serving the data, because that is an implementation detail mostly an implementation detail of the data product container, of the data product itself. And similarly with kind of the control endpoints like discoverability, and we'll see that also how that plays into the agent world and helps us there. But basically the actions here on top like discovery, observability, and the self-governing aspect, right? It is not one central system. It might use underlying central systems, but basically all the control is given to the autonomous data product. So let us look at a kind of concrete example how that would work also in an agent-like context. So here we have our customer feedback data product. I hope this is big enough, right? And that data product, it actually it consumes from 2 input data products. They are source aligned, so that's just raw data. And it has 2 kind of separate ones. So there's the point of sales customer feedback. Imagine you go to a store and you actually leave like some note, which you can still do in some stores. And the others is Amazon reviews. So that's kind of like very structured data down there. On top, it is more unstructured data. Imagine PDFs, document collection. The first thing our autonomous data products actually helps us to combine those is just by checking integrity and quality, right? Because if we have expectations, we got contracts on the input side, we can make sure we are only getting sensible data in there. Imagine there is a messed up PDF which isn't valid, which we don't actually want to feed into that. We can filter that out in the beginning. I think the second aspect of that is just the orchestration on the input side. So basically when to run. Do I want to run each time I'm getting a new Amazon review in my database? Probably not, because then I would just recompute everything all the time, which is also just a cost factor at a certain point. On the other hand, do I want to run only once a week when I'm getting those new PDFs in from all the stores? Probably also that is too slow. So the data product can actually decide and expose its own schedule sensors or triggers when to run, and I can coordinate it across different inputs. I might have like a sensor saying like, hey, I want to run based on this time schedule, but only if I at least have 20 new Amazon reviews on top, because otherwise it's not worth it. So I think this is kind of like on the input side here. On the output side, we got the same contracts, the same validation again. I can make sure I'm only exposing data. I'm not exposing any PII. I'm not exposing like any named information, which might be given out by my agent. And I think then the second aspect on the output side, interesting aspect, is about the multimodality. So we talked about it yesterday, actually, at the speaker dinner. The view we at Next Data have on autonomous data products is there's one semantic model, but that can be served in different forms, right? So it might be different consumers might have different needs how to consume that physical representation of that data. So for example, here is our customer feedback. I might have most of it, the structured information. I might write that out to ADLS or some kind of structured SQL database to be consumed by a dashboard or some data analyst. On the other hand, I might also write it out to documents to have it to train further machine learning models in a document-like form. And also for kind of RAG applications or agents, I might want to write that out into embeddings directly. So it is very different views, but it's still representing the same semantic information down there. And this also comes with like certain advantages. So for example, what I always find really hard is if I have a vector embedding to actually, because you can't really tell what's in there, to run any validations on that. But if I have those different models, I can run a lot of validations contracts on the structured data. And as I know it's all derived from like the same data, I can make certain well-based assumptions on the embeddings as well on top of that. So I think this multimodality on the output side and also on the input side, right? We are here consuming both structured and semi-structured document information is key to this entire GenAI area. How we at Next Data view kind of like the infrastructure plane. As I mentioned earlier, for the data product itself, it doesn't really matter what compute and what storage we are using. We have an open concept called drivers. So that's also, it's not to spoil too much, it's soon to be open spec, where everyone can come in and also write those drivers. So for example, right now we have drivers for Redshift, Snowflake, Databricks, and S3, et cetera, and they basically connect us to the underlying infrastructure plane for both the compute, but also the storage. So there's actually like very little to no data flowing into the system. So I'm saying very little because there's some discovery information, for example, some samples which might be running through the data product itself. But otherwise, the data, and also from like a compliance perspective, it's staying down here in the infrastructure plane down here. So let's actually try to turn that into a real thing. 15 minutes, right? I'll try to aim for like a live demo and connect that. Let's hope that works well. The Wi-Fi is a bit shaky here. And last thing before I jump in there, to maybe just give a bit of context, what I feel is changing, because we are building like an agent here. And just to give a bit of context, what I'll show in code in just a second, I think it's the agent lifecycle based on data products or based on domain-driven design, right? And that lifecycle is actually looking as follows. Like we have, as with any agent, we have like the intent discovery, right? I have a prompt in there. The LLM is going to evaluate that prompt and decide what to do. The next step is, I think, discovery of available data. So in terms of data mesh, you can imagine that's a question like, which data do I have available? Which data products do I have available for this particular problem? And I think then the important step here is then the sub-selection of the specific data to our problem. So which data products, which data do I actually want to expose the agent? And then we can go into like this normal loop of like data retrieval, get the data in, but only the specific data, and then we can make our decisions and agents. So I think the change there from like this more traditional, I struggle with using the word traditional with agents because it's all like so new, but kind of like that standard flow of agents is kind of this discovery and then the sub-selection part of it. And I think this is translating very well to data products and domain-driven design, because I can be specific about the information I want to expose to my agent. All right, with that, maybe a question: how many of you have seen Next Data OS like during the launch or? Yeah. Happy to answer questions. I don't want to go too much into detail of like a particular product here, but just to kind of like showcase how it matches to our GenAI, to this new world of autonomous data products. I wish there would be another implementation so I could compare and really just focus on autonomous data products. So here we have our different domains. If we zoom in a bit, we see also their relationships, and we can jump into a particular data product. Usually the data products being interesting to us are the ones which are red, which have an issue. So let's actually jump into multi-channel sales here. And I hope the internet is fast enough. Yeah. It's a bit slow, but I hope we are okay. So now we are basically switched from the mesh view to the data product specific view. And the first thing we can see is actually the semantic model out here. Or to be more precise, we got multiple semantic models we can go through. So in particular, we got three here. But this is basically what is being served and exposed for consumption by this data product. We also see the different outputs, and this is what I mentioned earlier, is the multi-model aspect, right? So all those different data models, they're going to be stored in both ADLS and Snowflake. And as I do have the permissions to the underlying storage, I could actually just go in and also request here an access token, a temporary access token for the underlying storage. But that only works because it is allowed by the policies in this mesh. Then we come to the more interesting side, and these are the promises. And this is also why we currently see why it's red. It's because our valid channel sales data velocity, data quality has been failing. And if I recall, this is, I think it's implemented a SODA promise. So this is again kind of like the idea of being extensible. We don't want to implement all the tools out there, but we want to be the glue, the orchestrator, bringing all of them together. And here we can see we are failing some of that, so probably someone should go in and then decide what to do. Those promises, they can have different consequences. So this promise, for example, is saying, oh, fail the data product in the end, and that's why we see it red. Another one might simply say, oh, don't expose the data, or in our terms, don't promote the data to the outside. So whatever data I've computed, my SparkJob running, don't expose that to any downstream consumers from me. We also have controls. So controls in this case here are just who has access to it. So for example, here, everyone can discover this data product, but only people in the sales and marketing domain can access the underlying data. So basically here, request a temporary token. And that is also, again, that's true for the agents running in there, right? So only the agents running within those domains or the respective service accounts, they would get access to the underlying data. All right, let's quickly jump into how do we connect this to this new world. I think this is kind of the hard part, which the Wi-Fi here was doubting me, so I just ran that over in the hotel. So I just connected Claude desktop against my data mesh. Each mesh is offering just a discovery MCP endpoint. So we can see here, if you're familiar with that, we can see these specific tools being offered. So for example, list meshes. This is just if you have multiple data mesh instances and you want to differentiate between them. But then also get data products, so we can get these specific data products for a particular mesh. In this case, we are going for our demo mesh here. And I can basically now ask natural language questions against my mesh. I can discover new data products. I can give it a chance to rerun later, but I said like the hotel Wi-Fi, the venue Wi-Fi was really picky with Claude here, so that's why I ran it a bit earlier. But basically, we can see this pattern. We are first selecting our data products, and then for each of them, we are getting more details. And I don't have to specify that really all I put into Claude is this information, and I can discover a number of data products down here, which are then being described. So I think this would be connecting like a chatbot, connecting like a natural language applications against your mesh, and then going down also to the data product API. A bit more complex example would be writing an agent. If you've seen like our launch videos, this is the actual implementation for our Promotee agent. So the Promotee agent, it's supposed to create marketing campaigns based on like new sales trends. And what I really like about this new world of agentic, it's really easy to specify that, right? It's just this natural language code here. This is the actual code. I don't think it's in a public repo, but fairly straightforward. And I think this is a pattern with all kind of autonomous, or with all data products, autonomous at least, and data meshes I can apply. So basically just a description like that, right? The first part of the prompt is retrieve data product name and outputs from Next Data OS related in the sales and product domain. And then we kind of like filter it down. So in our case, to make it very simple, I only look for data products offering a vector embedding output, but this can be anything, right? This is kind of the select step we saw earlier. And then I say like what to do with that data. So for each matching data product, retrieve the latest data, and then create promotional campaigns based on these examples. And this is really like all the code you have to write for an agent, because most of the complexity is given to it by those tools. So the first thing, this is also what we used earlier with Claude, is the Next Data, like mesh level APIs. So that mesh level, it gives me information about the data products being served there and available. The next part of it is a tool giving me access to recent data. Why I personally, that was like a personal choice, why I separated that. For me, the mesh level APIs, they only give me access to metadata. And just for regulatory reasons, I moved the stuff touching the actual data, retrieving data samples to a different tool being out there. I think I've seen other people who would merge that together. For me, it's just a difference whether I'm touching up on metadata or whether I'm touching up on actual data out there. And then the last thing, this is just like the tool to actually create promotional campaigns. This is kind of just the action being happening there. But I think this is a very standard pattern of going from the mesh level to data or individual data products, and then having some kind of action out in that field. Again, I would run that, just the LLM connection was very spotty, so I'm not going to dare my luck in running that live. With that, let's quickly jump back here and leave maybe a few minutes for questions. But for me, the big realization, and I think you had a similar slide on Wednesday. Who's familiar with this image from the book? I think most people, right? So that was kind of like 6 years ago, where the approach to data management was all about like, how can we have business impact? And with the more data sources we add, the more data we add to our data lake, the actual use and business impact is going to go down after a certain inflection point. And this is where data mesh and the domain-specific data products can actually help us overcome this inflection point. That was like one of the key value propositions of data mesh. And if we take a look at this today, I actually feel we have the same problem in the GenAI business world value, right? If we're starting out with just pure ChatGPT and you ask it about yourself, it's going to give you pretty bad answers. If you start adding more data about you, you're uploading your CV, you're giving it websites, etc., it's going to get better, right? You're going to get better answers from ChatGPT. Your agents are going to perform better until this particular inflection point. After that, if you give it more data, so if you make, for example, more data available to your RAG, or what you can also test yourself is just the number of MCP tools and resources you make available to your agent, to your tool. In my experience, like after 10, 20 tools, the LLM is just going to break down and not know which tools to choose. So basically, how much context you make available to the LLM is really limited, because otherwise it will be overloaded. And this again is where data mesh, or in other terms, domain-driven design, can help us by only making specific information or context. So information context also would, for example, include MCP tools. I'm not going to give it like all the tools available there, but I'm first going to check what do you want to do, and then I can, with dynamic discovery of tools, I can make the additional tools available. So this is what I, in general, really like about data mesh, that all those central ideas, they also apply to this new world. So it's nothing fundamentally changing because we're solving the underlying fundamental problem. And with that, we are also like safe in this new fast-moving world of GenAI and whatever might come over tomorrow. Cool. With that, thank you so much for listening. Thank you so much for being here. Super excited to have Tom organize this conference. Thanks also to you.
Thank you, Jörg.